We did a little bit of quick review of perimeter and area from the old to-doodles, and now we're ready to talk about the area of other polygons. Somebody was starting. Go ahead, do your highlighting. Don't worry about filling it in very solid. Just mark 3 different columns for that one. Those are 3 individual squares. Can you do it so that you're coloring a column at a time all the way down? And somebody else do shading 2 rows. So shade the 2 rows of the top version. That's good shading of a column. On the top, let's do the rows though. Can I hit undo and erase your columns? Or do you want to?
You can. I'm having problems with it.
Oh, okay.
Please.
Come there. Okay, you had just done the top row, but now you can do it again. Somebody shade 2 rows, somebody shade 3 columns. What's happening? Where is everybody?
Mine is not wanting to work.
Here's not. Okay, thank you for trying. Okay, I will help. Someone is doing the top very nicely. I will do the top other one. Okay, so the point of all that was that you could think of this rectangle as two different threes or as three different twos. They both work, and 3 times 2 is 6 either way. It doesn't matter which one you think of as sort of the thing and which one is how many copies. It works either way when you think about it. So that's how multiplication for squares and rectangles work. It's length times width or base times height, whatever you want to call it. You take the number on one side and the number on the other kind of side and multiply them together. For triangles, what happens? We have a triangle here. If I duplicate it, can someone grab the duplicate and spin it around? Or is that too much mouse trickiness? Especially with April on a phone, I'm not sure if she can. But if you tap on it, it should turn into, there should be a spot you can tap or click to rotate it and flip it over.
I'm on a laptop. I just having problems with it right now.
Ah, okay. I'm glad you got a laptop. There you go. So if I line them up for you, then you can see that two triangles make the rectangle. So if this is a base and this is a height, if I do all of base times height, that's the whole thing, the whole rectangle. So each rectangle is half of the base times height. And you've probably seen that formula, either half base times height, or just do the base times height and then divide by 2 at the end. So we've done two things. We've done rectangles, length times width, base times height, whatever you want to call it. And then triangles, so half of base times height, or base times height divided by 2. But that was a pretty easy triangle. You could just see that kind of this part and that part were the same. What about this triangle? How can you show that it is half of the rectangle that surrounds it? If you grab parts of it, you'll see they slide around. Do some sliding and convince yourself that it's half of the rectangle. Don't need to flip this one around. Can I reorient it back to beginning for you? So I have this green rectangle. I've put it in a box. And if I take this part of the box and move it over here, so I've taken what I've colored yellow and moved it over there. Does it look more right now that this is the same size as that? And if you believe me that my two red triangles are the same, then it makes sense that my original triangle is half of its box, because the box was just the original triangle and these other two pieces. So if you can put that into your own words, then you can show how any triangle is going to be half of the box around it. In other words, base times height, and then divided by 2 at the end. Or half of base times height. Anyone need me to talk about this more? No, okay. Other shapes. There's a parallelogram. That's the one that looks like a rectangle that an elephant sat on. And we want to show that it has the same area as the rectangle that comes up from its base. So we want to make the parallelogram into that. How would you do that? Try pulling on it. So now you've shown that that's how big it is. All you did was you took this piece and moved it over there. So it is, there's a base and there's a height, and we're just multiplying them together to get the area because it's a rectangle. That means with my original parallelogram, these diagonal edges don't matter. They are just a distraction that might be put on the GED to trick you. They are not part of the rectangle, and area is always about rectangles. So instead, what you need for the parallelogram is its height. Why do we need that height? Because that's the height of the rectangle that we're making out of it. Anyone want me to say that in different words?
Yes.
Yes, okay. So the only thing that makes sense for area is if we can make squares, because that's how we've defined area. How many tiles, how many squares fill up the spot. So we have to make things equivalent to rectangles, or it doesn't really make sense. For triangles, we can make them equivalent to rectangles. We photocopied it and kind of flipped it over. Since we had 2 of them to make a rectangle, we had to do a divided by 2 for how much each one takes up. Same kind of thing for the other triangle. For the parallelogram, we are saying that this parallelogram takes up the same space as this rectangle. The red one, how much area does it have? Height times base, so the parallelogram is the same. How do we know that? Because if we cut off something and put it here, it's the same amount of space and it fills up that rectangle. And you see that this side is the same as that side. It's the height of the parallelogram.
Yes.
Okay, were those words good enough? If not, I can try something else.
Yeah, that was pretty good.
The trapezoid is confusing, and you don't have to actually memorize its formula. I don't think you have to memorize any of these. I think it gives them to you. But if you don't understand it, that's okay. I'm going to put in a new page that's blank. It's just make a comment that if you ever had to find the area of a trapezoid, then you could just say, I'm going to take my knife and slice it. And now I have two triangles, and you can do the triangle area formula. But if you are given the formula, it's not really that bad. All it says is that I can take my trapezoid, and if I photocopy it, see I'm moving like a copy of it, then I'll turn it upside down. And now I've made a parallelogram. We just found out that the area of the parallelogram was its base times its height. The height's not a problem. I'm just going to say height because that was how tall our original trapezoid was. But the base is a little tricky. It has two parts. There's that part, and then there's that part. You with me so far?
Yes.
So this blue part was what we called the bottom of the original one. Where did this little green distance come from? Well, that, before I moved things, used to be the top of the original one. So the parallelogram I'm making, I make by saying that the bottom plus the top is how far to go across this kind of big bottom shape. So that top plus bottom multiplied by the height is how much area this whole thing takes up. But just like with the triangle, I have two of them. So the area for each, I have to do a divided by 2 at the end. If I made a photocopy, I have to kind of pay for it by dividing by 2 at the end. So it's not that bad, right? Add two things, multiply by height, divide by 2. It's just a little bit bigger than base times height. So here's our summary page. Base times height for the square, the rectangle, and the parallelogram. Base times height divided by 2, or if you like the fraction version, half of base times height for the triangle. And something that is like base times height divided by 2 for the trapezoid, but what it's calling base is you have to add up the top and the bottom. Because when you made the bigger shape, they were next to each other. The point all of that is that these formulas, which will probably be given to you on your math tests, again, I don't think you have to memorize them, aren't just like magic things. It's not like Pythagoras went up to Mount Sinai and got magic formulas. You can see how they work, right? You can move the shapes around and say, we can turn things into rectangles. Or once we have parallelograms, we can turn things into parallelograms. So let's actually do this. What's the area of the 5 different shapes on the screen that have grids behind them? If Josie and Jaden, who did the same problems Tuesday, want to show off, they can, or we can let someone else take a turn. I'm happy to label things. If you want to shout at the camera and say, right, that the base of the first triangle is 4, I can write that on the board.
For the red one, the first one, it's 3 for the height,
Okay,
and then I forgot, is it 3 or that they count that like last square too? I forgot.
one square counts 2. So 1, 2, 3, 4. It's all the way across as far as the base goes.
Okay, so yeah, 4.
So what's the area?
So is it 12 divided by 2?
It is. Can you see that happening? Can you see that the whole thing is 12? And that the triangle has kind of the southwest half of it.
Yeah.
Yeah.
Okay, somebody talk through the blue triangle.
The height is 3. And then the bottom is 6.
Yes. Then do the formula. We do the 6 times the 3. What do we get?
18.
18, and then half of that.
Is it 8?
If you need to use a calculator, that's fine too. Calculator. By 2, 9. So 6 times 3 is 18. Then half of that is 9. You could always just count half the squares too. 1, 2, 3, 4, 5, 6, and then half of the 7 row, 7, 8, 9. So 9 of them is half of the thing. Okay, orange time.
So the bottom is 6.
It's actually not. That there are 6 squares, but the shape only goes to there.
Oh, 5.
5, yeah.
So I missed it. I was in the bathroom when you started it. So
That's okay.
so 3 down.
Yep.
And then it's 15.
Ta-da, that's it. So you can imagine taking this yellow piece, cutting it out, and then putting it over here. And you would see that it turns into this rectangle that's 3 by 5. Right now we're missing this kind of top little triangle, but that's where it would come from. Maybe that helps. Maybe my art is too poor. Okay, brown one.
The height is 3
Mhm.
and the bottom's 4.
Almost. Again, the shape doesn't go all the way across the bottom, so just use its own base.
Oh, it's 3.
Yeah. Then the tricky one, which isn't actually that bad. What's the top plus the bottom? So 1 and 1, 2, 3, and 5. So in this case, top plus bottom is 6. Then we're going to multiply it by the height. And we get 24. And then 24 divided by 2 is 12. Questions about that?
No.
No. Okay. So that's area. Hooray.